Number 3.
Number which one? 3. This is a no calculator problem. Remember, if they're circled, they are calculator. This is a no calculator. So what's the first thing you did, Alex?
Well, I changed 49 over to 1/4.
Now be careful. It wouldn't be 49 over 1/4.
Or 49 exponent.
To the 1/4. Yeah. The radical is a fractional exponent, so it'd be 49 to the 1/4. Okay, then what did you do?
I had it equal to x.
Okay.
And don't you put it to like 7 exponent x equals 49 to the 1/4?
That's absolutely perfect. There's other ways to do this problem, but that is absolutely fine. Then what?
That's kind of where it's.
Oh, no.
That's where I think I'm just confused.
Well, no, you're not confused. Look, Alex, look.
Oh, you make it 7 of the bases. 7 is the base.
Yeah. 49 is not some random generic number. I mean, it'd be different if that were like a 16 or something. But what about 49?
7 squared.
Yeah, so you have 7 to the x equals 7 squared to the 1/4. Now what do you do with those exponents?
Multiply.
So you have 7 to the x equal to 7 to the 1/2.
So that's equal to 1/2.
Yeah. Yeah, you knew how to do that. Anna?
I got that, but I don't know, I don't understand why they didn't just do 7 to the 1/2 in the first place. Like, why is it like 49 to
What?
Never mind. Never mind.
Okay. I didn't understand your question. Delaney? 14, write the equation of the asymptote. Okay, we talked about this yesterday. I think something very similar to it. What does 2 to the x look like? Well, what does just, forget that, what does just 2 to the x look like? You know that shape. That's the shape, that's exactly right. So this is y equals 2 to the x. Where is its asymptote? Where's the asymptote in that picture? Right here, x equals 0. That's the asymptote, right? Or not x equals 0, y equals 0, sorry. Y equals 0. This is the y equals 0. Now, what does that plus 4 do? Uh-oh, we're in trouble. When you tack the number on the end, it moves you up and down. If we had done this, that would move it left and right, right? So we're going to take this picture and move it up 4. So where's that asymptote going to be? If I take this one and move it up 4, now I'm going to have this picture. Where's it going to be? Y equals 4. All right. Oh, state the range. Okay, so what's the range then? We're looking now at this one right here. So what's the range? What are the y values? Not equal to, just greater than 4. Just greater than 4. Did you do your homework? Okay. Which one?
On number 18.
18.
I just plugged points in.
Uh-huh.
Is there a way to like do it without plugging points in though?
Yeah, we talked about that yesterday. We have there are 2 kinds of exponentials. One with a base bigger than 1, that's a growth function. And one with a base less than 1, that's a decay function. So what's the base in your problem? 1/2, less than 1. So it's going to be that shape. But this would be y equals 1/2 to the x. That would just be the regular function. Now, when you do a -1 on that, what does that do? Delaney, pay attention. What does that do when we put a -1 right there?
It goes to the right.
It goes to the right 1 unit. So you're going to take your basic picture and you're just gonna pick up all the points and move them over 1 unit to the right. So you end up with this picture.
On number 15, why do you, when you separate it all, why do you like get, and then you add and you get 0.4345, and then why do you, like, I click on the answer, it's like 3.4345, why do you have to add the 3?
This is number 15.
Yeah.
Okay, so what did you do first?
Well, I separated it in log base x, or log, yeah, of 2 plus another one of those, and then
Okay, so you broke 20 down. Tell me how you broke down 20. 2 times.
2 times 2 times 5.
Okay. Okay, so you said I've got the log of 2 plus the log of 2,
Yeah.
2, plus the log of 5, plus the log of x cubed.
So then
What's the log base x of x cubed?
3. So it's just 3. Okay.
That's gonna get added to whatever these numbers were here. All right, who else found something in here? Maggie?
For number 19, I didn't know how to find the initial value.
Okay, let's look at 19. I gotta get in my book to get that one. So, let's see. I took these out of the book because I was just too lazy to write them down. Page 347. Number 94. Okay, so we got the population of deer. What kind of function is this? What do we call these kinds of functions? It's not quadratic. It's not linear. It's not exponential. What is it? Guys, it's one of your 12 basic functions.
Exponential.
No, it's not exponential. Exponential looks like this. This is exponential. That's logistic, absolutely. This is a logistic function. And it says, what was the initial population of deer? This is an easy question if you've read the question. The question says, this equation gives you the population after T years. So if I say to you, what is the initial population? That's the population when T equals 0. Isn't that the beginning? So we're just going to let T be 0. Now, remember, anything to the 0 is 1. So your so this is 1 times 99. Your denominator is just 100, isn't it? So what's the initial population? 12. Deer. When will there be 1,000 deer? How will we do that? When will there be 1,000 deer? Yep, put 1,000 in the Y spot right here. So we have 1,000 equals 1,200 over 1 plus 99 e to the negative 0.4 t. How do we solve that? This is definitely a calculator problem, so it'll be 1,000 plus 99,000 e to the negative 0.4 t equals 1,200. Just multiply this over to here, or think about it as cross multiplying if that's easier for you. First step to solving, don't divide yet. Subtract 1,000. Now, divide. So we're gonna have 2 over 9, let's see, I can cancel out 2 zeros, over 990. Now what?
Log, ln.
Take the natural logarithm of both sides. What is the natural logarithm of e to the negative 0.4t? Negative 0.4t equals ln 2 over 990. So t equals ln 2 over 990 divided by negative 0.4. So that will be ln 2 divided by 990 divided by negative 0.4. Did you get about 15.5? And was that, what was that, days or weeks or what? Years. That's years. Oh, yeah, I guess years would make sense. Years. Everybody good with that? And then what is the maximum number of deer planned for the park? 1,200. 1,200, your limit to growth, 1,200. Oh, Katie, come on. I know this is extremely stimulating. Okay, who else had a question about one of these problems? Any other issues? Delaney? 20 is on the same page, but it's number 89. So they gave me another equation. Okay, what's your issue here, Delaney? Open your book. Okay, let's, Delaney, read the problem out loud to me.
Is it 98 or 99?
It's 89 on page 347.
Beer, Lambert, law of absorption applied to Lake Superior states that the light intensity I in lumens at a depth of x feet satisfies the equation.
This equation, yep.
Find the light intensity at a depth of 25 feet. I didn't know if I put the 25 for I.
Well, what do you think? Let's read that first sentence again. That if the law states that the light intensity I, so what does I stand for? The lumens, light intensity, which is measured in lumens, okay? At a depth of x feet. So what does x stand for? The depth, right? So what are you going to do with the 25? You're going to put it in for x. So this is just a plug and chug problem. You don't have to do anything except plug in 25. So when I do that, this ends up being negative 0.3125. Now, how do I solve this equation? All I've done is plug in the x value they gave me. I don't multiply by 12. Eventually I'll multiply by 12, but not right now.
Log makes a 10.
There's a 10 on this logarithm, that's a common logarithm, and you need to get rid of that, right? So what are you gonna write?
10 to the negative.
Exactly. And then I'll get this number, and then I'll times by 12. So it's about 5.84. And that would be all right. Anybody else have a question about one of the review 2 problems? Maggie?
21.
All right, what's your thought on 21?
Would you set it up with the 1,234 as the A, or the A, or the P?
Okay, yeah, well, we got to figure out which formula we're going to use here. Now, I'm looking at the problem, and there's one word, or 2 words maybe, that just pop off the page at me. Monthly payment. If I'm making a monthly payment, then what formula do I need?
The future value.
I need either future value or present value, so I'm going to find those. They're on another sheet here. So I've got my 2 formulas. They're on yesterday's sheet. Okay. Now, which is it? What am I trying to do here? Stephen, get your head up. What am I trying to do here in this problem, number 21? I'm paying something off, right? Not investing, not building up a future account value. I'm paying off what I owe right now, right? So which formula? PV. I'm going to use my PV formula. Which I just copied down right off the page. Now I'll look back at my problem and start putting this in. Where do I put the 1, 2, 3, 4? PV? That's the value of the loan right now. That's how much I borrowed. What do I put in for R? That's what I'm looking for. That's the payment, kids. R is the payment. Now, what do I put in? Oops. What do I put in for I? Be careful. What do I put in for I? 0.1849 divided by 12. 12 payments. Remember, your interest rate has to be subdivided per payment period. So 18.49% is for the whole year. This is what it is for a month then. And what power am I raising that to?
4.
No, not the 4th. The -48. You guys, come on now. We went through this. What do all these letters stand for? What does that N stand for? The number of payments you're making over the life of the loan.
So why is it 48?
Because it's 4 years of monthly payments. Delaney, get your head up. This I is the same as the other I. Now, am I going to need logarithms to solve this? No. All I really need to do, it's a pretty simple problem. I just need to get this number, and then I'll divide 1, 2, 3, 4 by that number. So I'm going to work on getting this number, and I can do that any way I want. You can actually type in the numerator exactly as it is. If you type it the way I wrote it, you can do it. So 1 minus parentheses 1 plus 0.1849 divided by 12, close the parentheses, and raise it to the -48th power. And then divide that by parentheses, 0.1849 divided by 12. And then divide 1, 2, 3, 4 by that answer. So the payment is about $36.57. Now, that doesn't seem like much, does it? Credit cards are bad things, people. Take $36.57 times 48, because that's how many payments you're making. So the total amount you'll pay on this little bill right here is $17.55, and you're thinking, oh, that's not that big a difference. Well, wait a minute. The percentage, you would be paying 42% more over that 4 years. You'd be paying 42% more than you borrowed. What's the moral of that story? Use your credit cards, all right, but what should you do? Pay them off every month. Pay them off every month. It's okay to use a credit card, but pay it off. Don't be making these payments because the interest is exorbitant. And you think, oh, I can afford $36 a month. Yeah, but you paid 42% more than you would have paid if you just paid it off in the beginning. Right? There's your conservative fiscal lesson for the day. All right, from the probably the most fiscal conservative person in the world. All right, here we go. Homework tonight is practice test.
Is that what you just handed out?
Nope. You already have practice test 1. I handed out practice test 2. Okay, so here we go. After looking at your quizzes and the makeup quizzes that I've graded so far, we are not going to take a test on Monday. We're going to take a test on Tuesday. However, I am sensitive to the fact that some of you may have bunches of things on Tuesday. So if you are able and would prefer, you may take the test Monday after school and then use first period as a resource or study hall. So if you feel at the end of Monday, Katie Klein, who's nodding with her eyes shut, if you feel that you are ready to go on Monday after school, then you may do that. I'm sorry for those of you that have other things that's not an option for. I don't know what else to do, but I have to do what's best to get a good grade in here, because the quarter's almost over. We only have a couple weeks left after next week, okay? So tonight's homework, practice test 1. Monday night's homework will be practice test 2. We take our test on Tuesday. Everybody clear on that? And you have some time right now. You can get started. I will be wandering around or doing something, and you can ask me for help if you've got a question. If you have makeup work to do, it would be great if you could get that done next week.